Good evening, everyone. Welcome to the homework portal. Today we'll be solving the third problem. Okay, let me share my screen. I hope you are all doing well. You're learning the data analysis part. So this whole week, as I told you, we'll be doing only problems on data analysis and nothing else. Okay, so let us begin with this. Right. This question is something like this. It says a particular semiconductor device generates an EMF. Okay, so this generates an EMF. Why is it not writing? Okay, so this question is for 2 plus 1, 3 plus 1, 4 plus 1, 5, 5 plus 2, 7, 8, 10, 11 marks. Once again, this is also for 11 marks. Let me input it for 11 marks. Right, 11 minutes. A particular semiconductor device generates an EMF. This is generating an EMF. Okay, which varies with light intensity. So when light falls onto it, it is generating an EMF. Okay. The diagram shows a experimental element which a student used to investigate the variation with distance d of the EMF. Okay. So next, the output power of the lamp was constant. So here you are generating this EMF because this light is getting on. Light ons and you are moving this one away or nearby. Right. Table shows how E varies with D. So the experiment is okay, you bring this one nearby here, okay, along with the setup. This will generate a larger EMF. If you move farther away, it will generate a smaller EMF. That's it. Okay, very simple. So towards it, so this is the tabular column given here. So EMF is generated here is 5.5 volt and the distance was 19.1. When you bring this one here nearby 6 millivolt, when it is 18 centimeter, 8.6 millivolts, 16 centimeter, 11.9. See, the EMF is now seen to be increasing here. When it comes to 10 centimeter, half the distance, when you put it over here, okay, it is observed that it is generating an EMF of around 37.5 millivolt. Wow, good. Okay. So outline why the student has recorded EMF values different numbers of significant digits on the same number of decimal places. Now, what is the number of significant digits here? See, there are 2 here, 2 here, 2 here, 3 here, 3 here, and 3 here. Though he's using the same equipment, everything is same, why should he use different significant digits? Simple answer is that maybe the meter that I have kept here is having capacity of 1 decimal point, right? That could be one of the reasons. So I can say meter used. Which one? EMF meter, or what you call as potentiometer or voltmeter. Voltmeter use as 1 decimal place. Has, instead of saying 1 decimal place, you can say 0.1 volt, 0.1 volt as its least count, the least measured value. That could be one of the reasons. It's asking for 2 reasons. So how do I say on second reason? Second reason, put it as maybe you can say it depends on the accuracy. Accuracy. He wants to have more accuracy. So as a result of it, he doesn't want to start with 5, but he wishes to go with the available unit also. Okay, so 2 marks you will definitely get here. Next one. The graph shows some of the data points with the stationary uncertainty in the D values. On the graph, draw the data point corresponding to the value of D equal to 19.1 centimeter. Where's the graph? Graph is here. Oh my God, he has given you a line graph, and sorry, a scatter plot. And he's asking you to plot a value at 19.1 centimeter. Where is 18? 18 is here. 19 should be here. But where will I plot? Will I plot it here? Will I plot it here? Will I plot it here? Not known, right? Let us keep this question a little bit now. And let us look at what are the other questions. Maybe what can happen is this question can be attempted at the end. And these 2 questions have to be attempted first. Assuming that there is a constant absolute uncertainty in measuring all the values of D, draw the error bar for the data point in B. Okay, both these are related here. Okay, if you know where is that point, you can draw the absolute uncertainty also. Sketch the line of best fit for all the plotted points. Now what we will do is first let us sketch the line for all the plotted points. So what do we do? Let me write it down like this over here. So we start from here. This is what I have. I can put it by line. If I have 3 points, it's well and fine. What I'll do is I'll just reduce the scale so that I get a clarity on the whole picture. Okay, if I take only one part of it, I will not be able to do it, right? So I'll take it like this. And array, no, I am not getting it correctly. Let me erase this off. This is incorrect. It's totally incorrect. Okay, because I need a smooth line to be drawn. I'll expand this only. Okay, so and then I will now draw this one here so that I get a proper one. The pen and paper, you will be able to do it correctly, but in a digital, this one you will not be able. Okay, so partly it is coming. I don't know why they are making a mistake here. So it's array. Sure. Okay, anyway, so this is what you need to do. The plot should pass through all the points as much as possible. Let me try drawing it correctly. Otherwise, it doesn't look nice. Passes like this. And here, passes like this. Okay, it has to pass through it. I'm not getting the correct line over here. And they should also pass like this over here. It should pass like this over here. Okay. Now, so therefore we have got this. And if the trend line goes like this over here, it goes like this. Then according to 19.1 is 19 is here, 19.1 should be midway between these two. 19.1 should be over here. Okay, now what is it asked here? He has asked you to draw the data point corresponding to d equal to 19.1 and put the uncertainty also. 19.1 is here. This is your 19.1. Uncertainty will be horizontal uncertainty. And see here what has happened. 1 unit square they have taken. So with respect to this, you will also have 1 unit square here, 1 unit square here. And you put it like this over here. Okay, so thus we have got this. Now everything has been done. Next. All values of E have a percentage uncertainty of 3%. What is being given? Percentage uncertainty for E, which means he is giving you delta E by E equal to 3%. Okay. Calculate the percentage uncertainty in the product DE for the value of D equal to 18 centimeter. For the value of D equal to 18 centimeter. Now what we'll do is whenever you have a products like this, you just assume Y is equal to DE. Okay. And then delta Y by Y is equal to delta D by D plus delta E by E. Now delta E by E is already given to you as 3%. 3% over here plus what is delta D by D for 18 centimeter? Go back to the graph. 18 centimeter is here. 18 centimeters at this point. So it is covering only 1 unit over here. Okay, delta D by D. So this is 14, this is 16. Okay, 16, 17, 18. This will be your 17. Every unit here is only 0.2 centimeter. So therefore this unit should be 0.2. Okay, this horizontal bar from the mean position here, from here to here, it should be 0.2 centimeter, which means what is given? Delta D is 0.2 centimeter. So delta D is 0.2 centimeter divided by the value of D, which is 18 centimeter. Okay. So this should be 0.2 divided by 18 should be 0.1 by 9 plus 3. 3% is what? 3% is 0.03. That's what I should write. Don't just write 3 there. Okay. So here it is 3%. So therefore 0.1 by 9. Let me use my calculator. Where is it? Calculator. Yeah, it's here. So it should be 0.1 divided by 9 is equal to so much plus 0.03. When I do this, I get 0.041. 0.041. What is this now? This relative uncertainty is asking you percentage, which means multiply this by 100 so that you get the answer as 4.1%. You write this as nearly 4%. 4% is your answer. Okay, next equation. Next question. The student hypothesizes that there may be an exponential relationship between E and D in the form of something like E equal to A e to the power of minus KD. Deduce a suitable unit for K. Okay. Now E is equal to A e power minus KD. Take ln on both the sides. Ln E is equal to ln A minus KD, right? Because ln E to the power of minus KD will be minus KD. What do I need? I need the value of K. So how do I get the value of K? Okay, before doing this, what we'll do is we'll look at here. See, E is equal to A e power minus KD. So this e power minus KD should not have any units because exponential of that value, right? So if this should not have any units, this K into D should be a constant, that is units. It should be dimensionless. This should be dimensionless. This should be dimensionless. So therefore, unit of k should be equal to a constant divided by d. What is the unit of d? D is meters. So therefore, this should be 1 by meter, or this should be per meter. This is the way how you can do it instead of doing all this. Okay, next. Suggest a graph that the student should plot in order to get a straight line. Okay, if the hypothesis is valid. Okay, now you can use this one here. So here what do we get? You get ln E is equal to ln A minus KD. Ln E is what? E is a variable. So put Y here. Ln A is constant C minus K into X over here. X is a variable. So what is it you should plot? You should plot a graph of ln E versus D. When you do that, definitely you will get a straight line. Okay, but it will not pass through the origin, right? It only says, okay, it will not pass through the origin. Explain how can we obtain K using the graph. We can obtain K using the graph. See, when you put ln E versus D, ln E is along the y-axis, D is along the x-axis. Then you get y equal to minus kx plus c, which should be like this over here. So this will be your negative slope, which is equal to minus k. This k will be equal to minus of the slope value. When you do this, automatically you get the answer. Okay. So with this, we come to an end to the third problem. Now we are able to complete it within that stipulated time. Thank you. Let us look at the next video.